Hello, sir. I'm Varun Kumar and my registration number is 19BIT0058. I would like to start by introducing myself. So, I am currently a second year undergraduate pursuing my BTech in Information Technology from BIT University, Vellore. My current CGPA is 9.24. Talking about my hometown, I was born and brought up in Kanpur, which is a city in the Indian state of Uttar Pradesh. I belong to a nuclear family, which includes my father, my mother, and my brother, who also happens to be from VIT and is now working as a software engineer. So that was all about my family. Now, uh, apart from college, I also work as a part time software developer intern at a Bombay based startup called Codalize Technologies. I've been working there for the past 3 months. I work on technologies like React, React Native, Firebase, etc. to make both Android and iOS applications. So that was all about myself. So now I'd like to talk a little bit about why I chose to take object-oriented analysis and design subject instead of any other program elective. So I took software engineering previous sem. In software engineering, I learned about how the development of an actual software product takes place in the software industry. I learned about the various phases of the software development lifecycle. Earlier, I had this misconception that the development of a software just needed sitting down in front of the laptop and writing code. But after learning software engineering, I realized that there is so much of work, so much of planning and analysis that goes into the development of a real life software. So we learned about the various phases that are involved in the software development lifecycle, like requirements elicitation, requirements analysis, the design phase, the implementation phase, the testing phase, the deployment phase, and the maintenance phase. After that, in software engineering, we learned about the very basics of UML diagram. We learned about the use case diagram, the class diagram, the state transition diagram, the sequence diagram, the activity diagram. But I was pretty sure that there was much more to learn about UML diagrams than what we have learned in software engineering. So I researched a bit and found out that object-oriented analysis and design is a subject to go for if you want to dive deep into the concepts of UML diagram. So this was how I decided to take object-oriented analysis and design as a subject. And ever since then, I have learned so many new concepts about the various UML diagrams that I didn't know before. Even during review one of the OOAD project, a lot of my misconceptions about the use case diagrams and the class diagrams got cleared because of the suggestions that were given by you, which we later implemented in our project. So that was all about why I chose object-oriented analysis and design. So before moving on to how OOAD maps with the software industry, let's first understand the two major phases of object-oriented analysis and design. So the first phase is the analysis phase. The main aim of the analysis phase is to model the functional requirements of the software that we are producing without worrying about any of the implementation constraints. After the analysis phase comes the design phase. The aim of the design phase is to process the theoretical concepts and plans that are made in the analysis phase and find a way to implement those plans. Now let us see how OOAD maps to the software industry. Object-oriented analysis is the first technical activity that is performed as a part of any software engineering project. An analysis model is created using object-oriented analysis, which is transformed by object-oriented design into a design model that works as a plan for software creation. Object-oriented design results in a design having several levels of modularity. So a huge system is divided into smaller subsystems or modules which help in understanding the system in a better way and understanding how data is flowing across different modules and how various modules are communicating among each other. The principles of encapsulation and data hiding help the developer to develop foolproof systems that cannot be tampered by other parts of the system. It allows effective management of software complexity by the virtue of modularity, as we saw before. And it also enables easy upgradation of small systems to large systems. Now we see how the UML diagrams, which are an integral part of object-oriented analysis and design, are used in the software industry. The use case diagrams help the developers understand how a user might interact with the system, and it also helps the team to define and organize their requirements. A class diagram plays a vital role in the software development project. It helps illustrate the system structure in a detailed way and shows its attributes, operations, as well as the relationships among the various classes. It plays a significant role in object-oriented programming languages, and hence it is dispensable when it comes to software modeling. Sequence diagrams also help the software developers to see how objects and components interact with each other to complete a process. Similarly, other UML diagrams also play a major role in the software industry. So we see how object-oriented analysis maps very well with the software industry. So now we'll be talking about class diagrams. Class diagrams are one of the most important UML diagrams. So much so that they are also sometimes referred to as the heart of UML diagrams. This is because there are many other UML diagrams are derived from the class diagrams. So the class diagrams form the basis of many other UML diagrams. So before moving on to the various components of the class diagram, let's first understand what are the objectives of class diagram. So the class diagram provides a static view of the system. It describes the responsibilities that the system has to perform, and it also forms the base for other UML diagrams like the component diagrams and the deployment diagrams. So the basic component of a class diagram is a class. A class has the following three components. The uppermost section describes the name of the class. Then the middle section contains the attributes of the class. The attributes describe the various properties of the class, and the lowermost section contains the methods which define how this class shall interact with the data present in the system. Moving on, we have various visibility modes for each attribute and each member method. The plus sign indicates that the the particular attribute or the particular data member is accessible by all the other members of all other classes. The minus sign indicates that the particular attribute is a private attribute and it is only accessible by the methods of that particular class, and the pound symbol represents that the attribute is a protected attribute, which means that the attribute is only accessible by that particular class and the methods of the class which are inherited from this class. So that was about the visibility. So now let's have a look at the various kinds of relationships that can exist between the various classes in a class diagram. So we are basically going to discuss four kinds of relationship: that's inheritance, association, aggregation, and composition. Moving on to the first kind of relationship, that is inheritance. Inheritance is a kind of relationship in which the associated class is a child class which has all the functionalities of the parent class and some extra functionalities. The class whose functionalities are being inherited is called the parent class or the super class or the base class, and the class which is inheriting the properties of the base class, is called the child class or the subclass. To show inheritance in the class diagram, we represent it by a solid line from the child class to the superclass with the arrow pointing towards the superclass. This inheritance allows us to implement abstraction. Moving on to the next kind of relationship, the association relationship. The association relationship is a structural link between two peer classes. Here we can see that there is an association between a class 1 and class 2. Uh, so in association, there is no dependencies between the class 1 and class 2. These class can exist on their own, but they are just connected by a simple relationship. The next kind of relationship is an aggregation relationship. An aggregation relationship is a special kind of association. In this kind of relationship, a part can exist outside of a whole. So even if one class gets destroyed, the other class can exist on its own. A composition relationship is another special kind of association where one class is highly dependent on the existence of other class. If the other class gets destroyed, uh, the class that is dependent on the other class also needs to be destroyed. So that was all about class diagram.